Hello everyone. Today I am here with you all with the last topic of class 10th mathematics, that is probability. So before starting with probability, let's see what probability is. We have seen in our day-to-day life people saying that there is 70% chances that India will win the match today. It's 30% chance that it is going to rain today. So whenever we are representing the chance of happening of any of the event quantitatively, it is your probability. Now, what all terms we use while talking about probability, just have a look over it. Experiment. What experiment is? An experiment is an operation that can produce some well-defined your results. So whatsoever the results an experiment can produce, these are known as your outcomes. Suppose I am saying that I am tossing a coin. So I know that whenever I'll toss a coin, either your head will come or tail will come. So the results which are well defined while we are performing any of the experiment, this is known as your outcomes. And whenever we are representing all the possible outcomes, it is known as your sample space. And sample space is how we are representing it. We write it as capital S, then your curly bracket, and whatsoever the possible outcomes are there, we are representing. This is your sample space where we are representing what all possible outcomes could be there while we are experimenting. We are doing any of the experiment. So experiment over here is like we are tossing a coin. It could be we are rolling a dice. So possible outcomes could be your one, either one will come or two will come or three or four or five or six. So whenever we are representing all this in the curly bracket, it becomes your sample space. So this is all possible outcomes we have written in the curly brackets. S is equivalent to all the possible outcomes and it is known as your sample space. Then there are two types of experiments are there. One is your deterministic experiment, another is your random or probabilistic experiment. So what deterministic experiments is, so whenever we are doing any of the experiment repeatedly, in the same way what we had done previously, means in the same identical conditions, if we are repeating the experiment and in all the cases our result is same, we say it to be deterministic experiment. Suppose we have to find your density of iron, and in the same condition, in the same temperature, in the same atmospheric pressure, we are conducting the experiments. So whatsoever the times we are going to repeat the experiment, always our result will be same. If we are going to find the freezing point of the ice, then whatsoever the condition, whatsoever the number of times we are going to repeat, if our probability, if your conditions are same, we will be getting the same results, and that type of experiments are known as your deterministic experiments. Now comes your random or probabilistic experiments. These are the experiments, if we are going to repeat these type of experiments in the same condition, then also we can have the different results. Like if in the same condition we are tossing a coin, so it is not always compulsory that always will be having head. It is not compulsory. Maybe it is sometimes we are getting head, maybe sometimes we are getting tail. So in the same condition we are repeating the experiment, still we are getting the different results. So these type of experiments are known as random or probabilistic experiments. Now what trial is? Trial is simply an action that results in either one or several types of outcomes. That is your trial. Now event is basically a collection of some outcomes. See, whenever we are conducting any of the experiments, so there are so many events are there. Like if we are tossing a coin, then one of the event is just getting a tail is one of the event. Getting a head is even one of the event. If we are rolling your dice, in that case getting one is one of the event. Getting even numbers could be one of the event. So whenever we are conducting any experiment, so collection of some outcomes is your event. If we are saying that there are total number of n outcomes are there, then event possible will be 2 raised to the power n. That means if n number of outcomes is possible from from your experiment, then the number of events will be given by 2 raised to the power n. And what is the probability of any of the event? Suppose E is the event, so probability of the event E will be number of outcomes which is favorable to the event divided by number of total possible outcomes. Suppose I am taking an example. Suppose I am saying that I am rolling a die, and what is the probability of getting even number? So total number of possible outcomes could be either 1 will come, 2 will come, 3, 4, 5, 6. These 6 are the possible outcomes. Out of this, which is favorable? For even numbers, 2 is the favorable condition, 4 is the favorable, and 6 is the favorable. So these 3 are the favorable condition. So number of outcomes favorable to E will be or 3, and number of total possible outcomes will be 6. That is 1 by 2 will be the possibility of the event. Over here we have taken getting a even number. If I am saying that getting a prime number is the event, so what is the possibility or what is the probability of it? So prime number over here we can see 2 is the prime number, 3 is the prime number, 5 is the prime number. So we are having 3 favorable conditions over here. So again your probability of getting a prime number will be number of outcomes that is favorable to it, that is again 3, and total number of possible outcomes, that is 6, that is 3 upon 6, it will be 1 by 2. Just now we have seen that what is event. Now let's see some of the types of events. Elementary event. If we are conducting any of the experiment, so we are having some well-defined outcomes we know. So if the number of outcome for any of the event is only 1, then we say such type of events as your elementary events. Suppose I am rolling a dice and I am saying that the event is getting a 2 is an event. So the favorable condition for this event will be if I am having 2 on the dice. This is only the favorable condition. If I am saying that getting 6 on the dice is the event, in that case, if there 6 is coming on the dice, it is only the favorable condition for the event. So whensoever there is only one outcome which is favorable for the event, such type of events are known as elementary event. And if for the experiment, whatsoever the outcomes are possible, if for all of them we are taking all the elementary events and if we are going to add them, the sum will always be 1. Say if I am tossing a coin, so the possible outcomes is either getting a head or getting a tail. So what is the probability of getting a head? So over here, total your outcomes possible or the sample space will be getting a head or getting a tail. This is the sample space. Now if I am saying that one of the event is getting a head, so it will be an elementary event because only one possible outcome is there which is favorable to the event. So probability of getting a head will be 1 by 2. Because total number of favorable outcomes is your 1 and total number of possible outcome is 2. So probability of getting head is your 1 by 2. Similarly, another elementary event could be getting a tail. These two are only the possible outcomes. So if I am saying that the event is getting a tail is an event, then probability of getting a tail will be 1 upon 2 only because favorable condition is 1 and total possible outcomes will be your 2. So it will be 1 upon 2. These two are the elementary events which is possible from this experiment. Now, if I am going to add these two, their sum will be 1. So whensoever we are taking all the elementary events related to some experiment, always their sum will be 1 always. Now take the compound event. As just now we said that in the case of elementary event, we are having only one outcome. Possible outcome could be there. But in the case of compound event, if we are having 2 or more than 2 outcomes possible for the event, whensoever we are conducting any experiment, such type of events are known as compound event. As just we discussed in this video only, that if I am saying that I am rolling a dice and the probability of getting an even number. So what it will be for this event, getting a even number is an event, and for this your favorable conditions are 2 is a favorable condition, 4 is the favorable condition and 6 is the favorable condition. Total out of 6 possible condition, that was your sample space was 1, 2, 3, 4, 5, 6. That means total 6 possible conditions were there. Out of this, your favorable condition is getting 2, 4 or 6. It is your favorable condition. So whensoever we are having 2 or more than 2 outcomes as your favorable condition, such type of events are known as your compound events. Similarly, if I am saying that getting a prime number is an event, in that case again we can say over here 2, 3, 5. All these 3 are your possible favorable outcomes. So because there are more than one possible outcomes are there for this event, so such type of events are known as compound event. Now let's see what is impossible event. Whensoever we are saying that we have conducted an experiment and whatsoever the possible outcomes are there, we know that. If whatsoever the event is there, which is not at all possible, it is not possible that we are, suppose I am rolling a dice again and I am saying that the event is getting 7 on the dice is an event. So we know that the possible outcomes could be either 1, 2, 3, 4, 5 or 6. We cannot get 7, we cannot get 8 on whenever we are rolling a dice. So such type of events which is not at all possible, it cannot happen in any of the condition, such type of events are known as impossible event. And the probability for these type of events is your 0. Why it is 0? Because the numerator over here, what we are saying, probability of any of the event, that is your number of possible favorable outcome divided by total number of possible outcomes. So favorable outcome over here, that is numerator is 0, and when numerator is 0, the probability of the impossible event will become 0. Now it is your sure event, it is even known as your certain event. When there is probability of getting an event is 100%. That means it is 100% sure that the event will happen whatsoever the condition is. Like if I am saying when I am rolling a dice, we are getting a number which is less than 7. So whatsoever the number will come, whether it is 1, 2, 3, 4, 5, 6, whatsoever the number will come, it is fulfilling our condition, that is it is always less than 7 only. So such type of events which is 100% sure it is going to happen, the probability is 100%, such type of events are known as sure event, and the probability for them is your 1. The probability for the sure event will be 1 because the numerator over here and the denominator over here will be same. Because if total number of possible outcome is 6, all the 6 are your favorable outcomes. So 6 by 6, that means 1 will be the probability of a sure event. Now, equally likely events. So whenever we are saying that we are just conducting an experiment and whatsoever the outcomes are possible, if the chances of getting each outcome is equally likely, means the chances of getting all the possible outcomes is same. Say getting a head while tossing a coin is the same, probability of getting a head is exactly same what is the probability of getting a tail. So when these type of conditions are there, when there is equal chances of getting the event, getting your outcome in any of the event, such type of events are known as equally likely events. Like if I am saying that getting a head is one of the event and getting a tail is one of the event while conducting an experiment, so there is equal possibility of getting either head or tail, so such type of events are known as equally likely events. But it is not the always case, but whenever we are talking about probability over here, most of the time we are taking the case when the your probability is equally likely events only we are taking. But if suppose I am saying that I am having a bag, and in that bag I am having 5 red balls and 2 white balls, and without seeing I am simply picking a ball. So what will be the probability of getting a red ball? So it won't be same as that of white ball, because there are 5 number of red balls are there and 2 number of white balls are there. So chances of getting a red ball is much more than getting a white ball. So that's the reason these type of cases are your unequally, it is not equal likely events when the probability is not same for getting the event, it is not same. Now what is the range of probability of an event? Just now we have seen if your event is impossible, its probability is 0. When it is your sure, the probability is 1. So probability of any of the event lies between 0 and 1. We are even including 0. It is for impossible events. We are even including 1 because it is for your sure events. So probability of any of the event always lies between 0 and 1. Somewhere in between 0 and 1. We are even including 0 and 1. Why it is so? Because see, what we had said is that probability of any of the event is total number of favorable outcome divided by total number of possible outcome. So whatsoever the possible outcome is there, obviously it will be more than the favorable outcomes. That means denominator is greater than the numerator, and when denominator is greater than the numerator, your value won't exceed 1. Right? And that's the reason range of the probability varies between 0, not between 0 and 1, because we are including 0 also and we are including 1 also. Now what is complementary event? Like if I am saying that event is your getting a head is a event. when we are tossing a coin, then getting a head is an event, then getting not head, if we are not getting head, it is your complement event, complementary event. That means if that event is not happening, it will be the complementary event. Suppose I'm saying that I'm rolling a dice and getting 3 is the event, then getting not 3 is the complement of the event. Like say if the probability of getting 3 is the event when I am rolling a dice, so what will be the probability? It will be 1 by 6, because your sample space will be 1, 2, 3, 4, 5, 6. This is the sample space. This is the possible outcomes. Out of this, getting a 3, that means only 1 is a favorable condition over here. So it will be 1 upon 6. That is probability of getting 3 is your 1 by 6. Now probability of not getting 6, not getting 3. Not getting 3 will be your, it is denoted by E bar. Probability of not getting 3. That will be, means favorable condition is, this is 1 is favorable condition, 2 is favorable condition, 4 is favorable, 5 is favorable, and 6 is favorable. That means these 5 are the favorable condition. So probability of not getting 3 will be 5 by 6. So whenever we are adding probability of getting an event and probability of not getting that event, always their sum will be 1. These are your complementary events. Like PE, if getting 3 is a event, then getting not 3 will be the complement of that event, complementary event of that, and sum of these will always be 1. This is the formula which is used for solving some type of questions, that it is given that probability of this event is this, so what will be the probability of not getting it? That means as a complement is asked, so we will be subtracting the probability of getting the event from 1 for getting probability of not getting the event. That means complementary of the event will be getting out of it. Now let's see some of the useful sample spaces for the type of questions generally asked. When a coin is tossed, when a single coin we have taken and we are tossing, so what could be the sample space? Either head will come or tail will come. This will be the sample space. When 2 coins are tossed once, a coin is tossed twice. Either we are saying that we are taking 2 coins and we are just tossing these 2 coins once, or we can say a coin is tossed twice. Yeah, otherwise we have taken a single coin and we are tossing it twice. So what will be the sample space? What will be the outcomes? So because 2 coins, either 2 coins are there or 1 coin is there which we have tossed twice. So outcomes will be either in both head will come, or in the first head will come and in the second tail will come, or in both the 2 coins tail will come, or we can say in first tail will come, in the second head will come. So these 4 will be the possible outcomes when either 2 coins are tossed once or a coin is tossed twice. Now if we, instead of 2 coins, we have taken 3 coins, and these 3 coins we are either tossing once, or we have taken 3 coins and we have taken 1 coin and we are tossing it thrice. Either of the 2 cases we can take, means when 3 coins we have taken and we, all these 3 coins we are tossing once. Otherwise what we can say it as, we have taken a coin and we are tossing it thrice. So what will be the sample space for that? Either in all the 3 cases your head will come, or in first 2 it is head is there, then tail will come. In first head, then tail, then head. On the first head will come, then 2 tails will come. This is the possibility when on the first it is head is there. Now other possibilities could be in all the 3 coins tail will come, otherwise 2 tails, 1 head, tail, head, tail, and tail, head, head. These 8 are the possibilities, these 8 are the outcomes possible when 3 coins are tossed once or a coin is tossed thrice. Now when a dice is rolled once, we are rolling the dice and once only we are rolling, so what all possible outcomes could be there? Either 1, 2, 3, 4, 5, 6. These are the possible outcomes. That means this is the sample space for it. Now instead of 1 dice, we are rolling 2 dice. Either we are rolling 2 dice once, or a die we are rolling twice. Either we have taken 2 separate dice and we are rolling them once, or otherwise we have taken a die and we are rolling that die twice. In this condition, what could be the sample space? So see over here, there could be 36 possibilities could be there. This we are taking as the first die, this we are taking as the second die. Suppose if on the first die 1 is coming, it is possible that on the second die even 1 will come. It is possible that on the first die it is 1, on the second die it is 2, on the first die it is 1, on the second die it is 3, on the second die it is 4, then it is 5, then it is 6. So for the first die we have kept 1 common over here, and for the second die we have changed the numbers 1, 2, 3, 4, 5, 6 we have taken. Similarly, it is even possible that on the first die 2 is coming, and then if 2 is coming, so either on the second die 1 could come, 2 could come, 3 could come. So similarly, we'll be making all the possible outcomes, and there will be 36 possible outcomes will be there when we will be rolling 2 dice once, or we are rolling a die twice. So now from here, what we could interpret, what type of questions could be asked over here, that how many doublet would be there. What doublet is? When the ordered pair of same numbers is there, we say it as doublet. That means your 1 1 is a doublet, 2 2 is a doublet, 3 3. When the same numbers are coming, it is your doublets. So these are the doublets. So total 6 doublets are possible when we are rolling this condition, when we are rolling 2 dice once, or we are rolling a die twice. So this 6 possible doublets are there. Now again, conditions could be asked is like when the sum of the numbers which are coming on the dice is 2. If the sum is 2, that means only one possibility is there. Then when both the numbers, both the die will have 1 at the top. That means this is the possibility when sum is your 2. In this condition, sum is your 2. When it is asked that sum is 3, in that case, see 2, 1 and 1, 2 are the condition when the sum of the dice, numbers on the dice will be 3. So these two are the possibilities when the sum will be 3. Now if the sum is 4, then 3, 1, 2, 2, 1, 3. These are the possibilities when the sum will be 4. When the sum will be 5, it is either 4, 1, 3, 2, 2, 3, 1, 4. These are the numbers when the sum will be 5. When the sum will be 6, it is 5, 1, 4, 2, 3, 3, 2, 4, 1, 5. These are the numbers when the sum will be your 6. So these are the numbers when the sum is 6. When the sum is 7, 6, 1, 5, 2, 4, 3, 3, 4, 2, 5 and 1, 6. These are the numbers when your sum will be 7. Then for 8, 6, 2, 5, 3, 4, 4, 3, 5, 6, 2. It is for the sum 8. For the sum 9, 6, 3, 5, 4, 4, 5, 3, 6. Over here, the sum of the two numbers will be 9. Sum will be 10 if it is 6, 4, 5, 5 or 4, 6. In this case, sum will be 10. Sum will be 11 when it is either 6, 5 or 5, 6. It is the case when sum will be 11, and this is the case when sum will be 12. So these are the numbers. We can easily find it out that how many numbers are there, how many possibilities are there when sum will be either starting from 2 to 12. How many outcomes are favorable for these type of conditions. So many type of questions could come, but these are some of the type of questions which could be asked when you are rolling 2 dice once, or you are rolling a dice twice. Now, if we are taking a coin is tossed, and along with that a die is rolled. One die we have taken and one coin we have taken. So on the coin either head will come or tail will come, or on the die either it will be 1, 2, 3, 4, 5, 6, any of these numbers. So if it is head on your coin, if it is head, then on the die it could be 1, 2, 3, 4, 5, 6. This is the condition. And if it is tail on the your coin, then again on the die it could be 1, 2, 3, 4, 5, 6. So this will be the sample space when a coin is tossed and a die is rolled. So hope it is clear. So how to find it out that what will be the sample space for the given conditions? It is very important to know, to find it out what the sample space is. Then only we can solve our problems accordingly. Now let's see some of the concepts related to playing cards. If you know how to play cards, you must be aware about it. So in the playing cards, total number of cards is 52. Out of these 52 cards, 26 cards are black in color and 26 cards are red in color. In the black color, there are two types of suits are there. One is your club, second is your spades. That means for every suit, there are 13 cards are there. 13 cards of club is there, that is, and 13 cards of spades is there, and the total will become 26. So these two type of suits are black in color. So total of these cards is your 26. For every type of suits, there are 13 cards. 13 cards of club, 13 cards of spades, total becomes 26, and these two are black in color. Now similarly, for 26 cards which are red, again there are two types of suits are there which are red in color. One is your diamond and another one is your hearts. So again there are 13 cards of diamond and there are 13 cards of hearts. Both are red in color. So total number of red cards is your 26. Now what these 13 cards are there, these 13 cards are common for all. So 13 cards is for every suit. These 13 cards are there. That is your one ace is there. Then number 2, 3, 4, 5, 6, 7, 8, 9, 10. One jack, one queen and one king. That is these 13 cards are available in all the suits. Right? That simply means for club also we are having these 13 cards. For the spades also we are having these 13 cards. For the diamond also we are having these 13 cards. And for the hearts also we are having these 13 cards. Now what type of questions are asked? That how many numbered cards are there? So what is numbered card over here? Out of these 13, how many numbered cards are there? This is your 2, 3, 4, 5, 6, 7, 8, 9, 10. From 2 to 10, that means in every suit, there are 9 cards are numbered cards. For every suit, 9 cards are there. And total number of suits are your 4 suits are there. So total number of numbered cards in 52 cards is 4, 9 is 36. That means out of 52, 36 cards are numbered cards. Now if we are talking about face cards, so jack, queen and king, they are known as face cards. So in every suit we are having one jack, one queen and one king. That means in every suit we are having 3 cards which are face cards, and total number of 4 suits we are having. That simply means total number of face cards in out of 52 cards will be 3 in each suit, and total 4 suits are there. That means 3 multiplied by 4, total number of 12 cards are there which are face cards. Now, if it is asked that how many honor cards are there, so what is honor cards? So in honor cards, we are including ace also. So when we are including ace, jack, queen and king, so these 4 cards are known as your honor cards. So in every suit, these 4 cards are there. So in every suit, because 4 cards are there, which is honored cards, and there are 4 suits are there. So total number of honor cards will be 4 multiplied by 4, that is 16 cards. So what type of questions could come? That the number of black cards. If we are going to take a card from a deck of 52 cards, so what is the probability of getting a black card? So we can see that there are total 52 cards are there. That means total possible outcome could be 52. And favorable condition is your 26 cards are black in color. So favorable condition is 26. So for getting a black card, the probability will be 26 by 52, that is 1 by 2. If it is asked that what is the probability of getting a numbered card, so total numbered card is 36 and total possible outcomes is 52. So it will be 36 divided by 52. So similarly, if we are knowing the concept of the cards, what card is known as what, like what are numbered cards, what are face cards, what are honor cards, we can solve the questions related to it. Now let's see what is fundamental principle of multiplication and what is fundamental principle of addition. Suppose there are 2 jobs are there. One of the job could be done in any of the m ways and another job could be done in any of the n ways. Now once first of the job is done out of m ways by any of the way, first job is done, then we will be doing the second job, and out of these n ways, the second job could be done by any of the way. Now if we will be doing these 2 jobs in succession, means one after the other, so there will be total m into n ways by which we can complete the whole work. That simply means if there are 2 jobs such that one of them can be completed in m ways, one of the job we can complete in m ways, and when it has been completed, in any of these ways, out of these m ways we have completed by any of the means, we have completed this job, then the second job can be completed in any of the n ways. Then two jobs in succession can be completed in m into n ways. Now let's see an example of it. Suppose there is a class, and in this class there are total number of boys is your 20 and total number of girls in the class is say 15. Now the teacher has to select one boy out of this 20 and one girl out of this 15 to represent the class. So how many ways will be there by which teacher can select one boy and one girl? Now see, over here two jobs are there. One is selection of a boy out of these 20. This 20 is your value of m. That means out of this 20, these 20 are the ways by which teacher can select one boy. N is your 15. There are 15 ways by which any of the girl can be selected. Now what she has to do is, first of all she has to select one boy out of these 20, and once she has selected the boy, then she has to select any girl out of these 15. So total how many ways could be there? Suppose I am saying that the boys are your B1, B2, B3, all these are your boys up to B20, and girls are your G1, G2, G3 up to G15 are the girls. Now suppose the teacher has selected boy as your B1. One of the jobs she has to do, she has to select one boy. Suppose she has selected B1, first boy. Then along with B1 she could have taken G1, first girl. Along with B1 she could have taken G2, second girl. Along with B1 she could have taken third girl. So that means along with B1 she is having 15 ways could be there that by which she can select any of the girl. Now there are 15 ways are there if she has selected B1 as the boy. Now suppose instead of B1 she has selected B2. Now along with B2 one of the girl could be your G1 also, could be your G2 also, could be G3 also, could be any of these 15 girls. That means again there are 15 chances, 15 ways by which she can select a girl. Similarly, till 20 it is your 20 times, it is your 15 chances are there of selection, 15 ways are there of selecting a boy and a girl, and if we will solve it, it will be 20 multiplied by 15, that is there are 300 ways by which teacher can select one boy and one girl for representing the class. So this is your fundamental principle of multiplication. Now let's see what is fundamental principle of addition. Again we are saying that there are two jobs such that they can be performed independently in m and n ways. First of the job can be completed in m ways independently, and the second of the job could be completed in n ways. Now then either of two jobs can be performed in m plus n ways. Now we have to do either of these two jobs. Now suppose the same type of condition I am taking, that suppose again there is a class in which number of boys is your 20 and number of girls is your 15. Again there is teacher is there and she has to select any of the boy or girl, means only one student she has to select and to represent the class. The student who is to be selected could be boy also or could be a girl also. Means any of the student out of these 35 she has to select for representing the class. That means over here selection of boy, if she is selecting, there are 20 ways of it, and for girl it is your 15 ways are there. So if she has to select independently any of the one way, any of the one student she has to select, so there will be 20 plus 15, that is your 35 ways of selection. She could have selected B1, she could have selected B2, she could have selected B3. So 20 options or 20 ways are there of selecting any of the boy, or there could be 15 ways of selecting any of the girl. So total number of ways by which she can select any of the student independently is your 35 ways. So this is your fundamental principle of addition. Hope the chapter is clear to you. This is all about this chapter. Soon we'll be coming with the video with the questions related to this chapter only, and many more videos. So if you have not yet subscribed my channel, please do subscribe it. Thank you.